One thing changed how we might interact with AI models across the board.
One thing, and we're starting there.
I'm Mila.
I'm Milo.
This is AI Daily, and later we're talking about a new on-device deepfake detection tool that runs in real time during video calls, which has some interesting implications for trust online.
OpenAI previewed its new GPT 5.6 model series late last week, introducing 3 distinct models: Sol, Terra, and Luna. Sol is the flagship, but Terra is designed to offer performance comparable to GPT 5.5 at half the cost.
Right, so it's not just about pushing the performance ceiling with Soul, which is what we typically expect from a new generation. It's also about democratizing access to near-frontier capabilities, making them significantly more affordable. The focus on cost reduction for a powerful model like Terra suggests a broader strategy to expand the user base.
Exactly. And Luna is even more specialized, focusing on speed and ultra-low pricing. This tiered approach means developers can select a model optimized for their specific application, whether it's raw power, cost efficiency, or speed. It moves beyond a one-size-fits-all model update.
That tracks. We've seen a lot of discussion around the economic viability of integrating advanced AI into widespread applications. If you can get near top-tier performance at half the price, that fundamentally shifts the unit economics for a lot of businesses. The open question is how quickly these reach general availability. OpenAI states it'll be in the coming weeks. WIRobotics this morning announced a technology disclosure roadmap aimed at building a physical AI development ecosystem for researchers and developers. The first release under this initiative is the simulation model for ALLEX, which is the company's humanoid robot.
And that's a significant move. We've seen a lot of progress in simulated environments for training AI, especially in robotics. Releasing a simulation model for a physical humanoid robot like ALLEX means researchers can iterate on control, perception, and interaction algorithms without needing immediate access to expensive, often scarce physical hardware.
That's the core of it. The stated goal is to gradually share additional core technologies from their humanoid robot program to support the broader AI community. It's an interesting play, essentially open sourcing parts of their development stack to accelerate a wider ecosystem around physical AI. The implications for collaborative research and embodied AI are substantial.
It also creates a potential standardized platform. If multiple research groups start building on the ALLEX simulation, it could lead to faster benchmarking and shared progress in areas like dexterous manipulation or navigation in complex environments. It's a foundational step towards something larger, essentially inviting others to build on their baseline. Scam.ai, in partnership with Qualcomm, launched a tool called Halo this morning. It's an on-device deepfake detection model designed for live video calls.
On-device for live video calls. That's the part that stands out. We've become accustomed to deepfake detection being a post-processing step, or something that happens server-side after the fact. Running it in the background of a video conference session to identify and flag synthetic or AI-generated video in real time is a different challenge entirely.
It means the processing power has to be local, on the device itself, and incredibly efficient to keep up with the video stream. This is where the Qualcomm partnership comes in, leveraging specialized hardware. The idea is that it could provide immediate alerts, making it harder for sophisticated deepfakes to be used in live interactive settings, like business meetings or sensitive personal calls.
The counterintuitive aspect here is the shift in trust. Instead of relying on a human to spot subtle inconsistencies or an external service to verify after the call, the device itself becomes the first line of defense, proactively flagging potential manipulation. It raises questions about how users will perceive these real-time alerts and integrate them into their understanding of a conversation. It's an attempt to restore a layer of trust directly within the communication channel. Also in AI today,
The U.S. government has partially lifted an export ban on Anthropic's Mythos 5, their cybersecurity model, allowing it to be redeployed to specific providers.
Anthropic has stated they are working to restore access for a small group of cyber defenders and infrastructure providers, hoping to expand access and eventually make their Fable 5 model available for general use.
Researchers at Google DeepMind have announced a new method for efficiently fine-tuning large language models using a novel parameter-efficient adaptation technique, showing improved performance on downstream tasks with fewer trainable parameters.
And finally, a report from the European Commission outlines new guidelines for AI developers regarding data governance and intellectual property, emphasizing transparency in data sourcing for training large models.
The shift toward more accessible, specialized, and secure AI models feels like the underlying current today.
It's a pragmatic evolution. The question is, how quickly do these specialized tools integrate into our daily digital interactions?